Thank you so much for joining us today, Dr. Casimo.
I'm Dr. Kaitlyn Casimo, she, her. I work at the Allen Institute, where I lead the Education and Engagement Program, which covers everything that basically is public-facing and educational. So things for students, things for teachers, for both the K-12 level and for college, training and professional education for working scientists, as well as outreach to the scientific community about what we do here at the Institute, and also our public outreach program where we reach our local Seattle community and let them know what's happening inside of that building they drive past all the time. I've been at the Institute for almost 6 years, and I did my PhD in neuroscience at the University of Washington before that. Yeah, so my undergrad is in neuroscience with also theater and psychology, and then my PhD is also in neuroscience, and that's actually pretty unusual around here. And in neuroscience in general, a very large number of people who work in the field of neuroscience, their degree actually says biology or psychology or math or something else on it. So first of all, my perspective is unusual in doing scientific outreach because of the nature of my training, which is extremely interdisciplinary, not just science and theater, but also within neuroscience that I've touched on psychology and computational neuroscience, and over the course of my career, much more. The influence that my theater training has had on my approach to science communication is, I can't separate the two out. It is one and the same. The practice of theater, both on and off stage, is about developing material and the performance of that material in a way that connects with your audience, whoever that audience is. So when we are doing science communication, when I'm doing it myself or when I'm helping other people improve their skills or facilitating science communication opportunities, we are taking scientific material and trying to make it resonate with whatever our audience is. The nature of the program here at the Allen Institute is that we cover a wide range of audiences, everyone from, little tiny children all the way through working scientists at the peak of their career. So the content requires that we understand our audience in a way that I really draw on my theater training for both understanding what content will resonate with people and how you deliver it will resonate with people. And then from a training perspective, I also lead our science communication training program for our own staff. So using those theater skills of performance, of improvisation, of connecting with an audience, infuses the entire performance and coaching of performances for people. In addition to all of that, science does not take place in a vacuum. Science happens in society. We tell ourselves stories about the science that we encounter in our everyday lives, not just science, all of STEM. And that theater is a way that I understand the world. It's a artistic medium that we can use to understand the world we live in and process our feelings about it. And that science doesn't come up all that often in not just theater, but especially theater, and in a lot of the media that we enjoy, like real science. Science fiction can help us process real science and technology, but the real science is actually surprisingly rare to experience in media. So that's another way that theater and storytelling helps us understand the world, and that I see that there's an underserved niche there. So my recent article on teaching and training with open science, it really is entirely drawn from my own work. It is really encapsulating the principles that we teach people with and the practical approaches to it in the form of a journal article. So everything that's in there draws from my own personal experience in developing more interactive, more engaging, more innovative ways to bring, in that particular article, focusing on scientific training to scientific professionals. But in some sense, a lot of those principles apply to many different audiences. Especially, we also work a lot with teachers as professional audiences, as well as with scientists as professional audiences. And, you have to understand, how is this thing going to fit into a person's everyday life? What can we offer them that will take them down a journey from, this is a thing that I am interested in, that seems cool, to this is a thing that sounds cool enough that I want to actually use it, to this is a thing that I am successfully prepared to use in a practical fashion. And that last step is frequently the most difficult one. It is not enough to just release data and tools and other scientific resources openly for people to use in their work. You have to offer training resources, whether that be an in-person workshop or a webinar or a written tutorial or a forum where people can answer questions. There's lots of different right answers to what training can mean. But if you don't offer that, then the only people who are going to be able to go down that journey are the ones who already have the resources, the time, the money, the connections to learn how to use this new thing. If you don't offer it, it's only going to reach the people who are already insiders in that world. And by training people, we can make these open resources, which are so powerful, more accessible and more practically usable to anyone. When I was in elementary school, I had an outstanding science teacher. My elementary school had a science teacher to start. That a lot of people's science education is not as supportive and encouraging and inclusive an environment as the one that I was fortunate to enjoy. Studies indicate that if children have decided by the age of, there's sort of two phases where they might no longer feel like they can be a scientist. There's one that's sort of in the elementary school zone, and then there's another zone in a roughly middle school. And once you lose a kid because they don't feel like they can be a scientist, because they don't see themselves as someone who can be part of the scientific community, because they don't realize there is a scientific community they can be part of, because they feel like they're not smart enough to be a scientist, or just because they didn't receive science exposure, not just education, but just exposure to science that felt like something that connected to their interests in their daily lives. Once they've decided they can't do it, they're gone. It's really hard to get them back into considering that this is a career they could choose. So I would say something that we do in our education program is we try to make research experiences and exposure to current research accessible to students at relatively young ages. So a lot of our programs and resources and teacher resources that are geared towards, say, the high school level, the goal of those resources and programs is to get Allen Institute open data into the hands of high school students. The scale of the data here at the Institute is such that they can do a genuine scientific discovery using purely data that's available on our websites, that they can come up with something truly novel. And that is a really encouraging experience for a student to say, what I'm doing matters. It's not just memorizing things. It's not just understanding processes. It's coming up with something new, and you feel like you've contributed. For students younger than that, who maybe aren't quite ready to dive in to the deep end of the data and tools, even just exposure to the fact that the biology is a wide open field, that there's a lot of cutting edge research happening, and it's happening here in our community, is something that we hope that students can relate to, especially when they can form a personal connection to one of our staff members, which I will say staff member and not scientist, because there's a lot of people who make the science world go round who are not the people at the lab bench or doing the data analysis. And those people are just as crucial to the practice of science as the people who are, in the lab with their pipettes. One area that we're really pushing and trying to innovate in science education is using open data as a lever to help provide authentic, hands-on, engaging science experiences for students. And then for students who are younger than that, providing exposure to careers, to scientists who are working in the field, to non-scientists who are working in the field, to make them feel like there are exciting things happening here and they belong here. Two of the key skills that I find are really valuable for scientists to develop that draw on my theater experience is, one, presenting with your whole self, using your face, using your hands, using your whole body, using your voice in its full range of expression. It's easy to fall into this sort of giving a lecture kind of feel. But if you're excited about what you're doing, which you are, because you wouldn't be doing this work if you weren't, then you let it show. Engage with the audience, show that you're a human who did this research, and that is something that is a learned skill, is performing with your whole self, your whole body, your whole voice, your whole face. The other skill that I think is really valuable for scientists to cultivate is the ability to improvise, which I don't mean whose line is it anyway, improv. I mean listening, really listening to what the person that you're talking to is saying and understanding the intent behind what they say, because sometimes the question is not actually the question. Then responding to it and not just continuing on with your sort of pre-prepared, abstract points. So to really take what the person that you are talking to, maybe it's someone asking a question at a presentation. I give a lot of our tours here at the Institute. So what kinds of questions do we get on tours, and what is the real intent behind the question? Or sometimes when you get those, well, this is more of a comment than a question, it turns out there actually is a question in there if you really stop to listen and react in the moment and improvise your response instead of just chugging along with what you already had planned. Yeah, so I've alluded to this throughout our conversation, but the Allen Institute practices open science, which means releasing data, tools, lab resources, protocols, and so many other types of scientific resource publicly for other people to use. And in particular, data we release publicly through websites, through brain-map.org, allencell.org, and explore.allenimmunology.org. And that is also where you'll find links to a lot of code repos and software tools that people can use, that we use to analyze their own data and others can use on their data as well. So open science, by the nature of these tools being released publicly and freely, can be a great vector for equity in science, for access to scientific opportunities. People can we have enough data and tools that people could do an entire PhD dissertation without ever setting foot in the lab using purely open resources. And that what we do in education and engagement empowers those people to actually be able to take that theoretical option of using open data and tools in their work and getting through that initial, okay, this sounds like a great fit, but how do I actually use it phase, as well as actually learning about it in the first place, because we go to conferences and we share the news about what kinds of things that we do. Open science by itself is a huge and powerful movement in science for improving the amount of knowledge, increasing the amount of knowledge that we get out of the data that we collect, for getting more out of our investment in that research, for bringing the whole field along by improving access to resources, by disseminating standards, by generating resources that are broadly applicable. And that what my goal is to help make sure that people don't have to have pre-existing access to training resources or pre-existing access to people who can answer questions in order to do that. One place where I really think about neuroscience in my daily life is that I play tennis, and that the way I think about how I track the ball as I play And the way that I respond to that is been completely overhauled by my understanding of how vision works in the brain and how your body controls movement. The tennis ball moves faster, and you have to respond faster than your visual system can actually keep up with. There's quite a bit of a delay. I don't remember exactly what it is in visual processing, and that your brain basically like fast forwards it to give you the impression that what you're seeing is happening in real time, and it's not. And in most activities, it doesn't matter. Like the delay, you know, when you're out like walking down the street, is negligible enough that it doesn't affect anything. But when you're playing sports that involve like a fast moving ball, like tennis, and when you're driving, that delay is really meaningful. And that what you're not actually responding to where the location of the ball is, you're responding to the location of the ball like 250 milliseconds ago. I'm not very fast. I'm like not a very fast runner. So my game has always relied on being like anticipating what's going to happen next and understanding how the visual system is really quite slow, and how that gets translated into a motor response, which then actually has to get physically sent out to your body and then implemented. And then of course, like, you know, it takes time to swing the racket, has really put an even bigger emphasis and understanding for me on that anticipation angle of my game. How do I like to express myself creatively and artistically? I feel like this one's kind of a gimme that it's theater. I go to theater all the time. I am still very much creatively engaged in theater. I have been since I think I was 4 in my first play. I was in Goldilocks and the Three Bears, and I played Goldilocks. So theater, engaging with theater is definitely the main sort of creative and artistic outlet for me. I also knit. So that's another very creative outlet for me. When I was in high school, I volunteered at the zoo. I'm from the Portland area. This was the Oregon Zoo. And at the time I did a lot of outreach, both at the zoo and in my community, around conservation and climate change. And I didn't know at the time that science communication was a career. Like, that's its own job. That is what I do now. I don't work in the lab anymore. I don't do science research anymore. But I couldn't do what I do now if I didn't have a science research background and science research experience. But I wish I had known that science communication was its own career, because with my background in both science and theater, it is something that, you know, fits my skills really well. And it's something that hits those 2 points of interest and joy for me. And I wish I had known sooner that that was something I could do as my whole career. I get to work with so many different scientists who do so many different types of really cool, cutting edge, you know, really high impact research. And I get to work with so many teachers and students and members of our community that research makes a difference in their education and makes a difference in their understanding of how science impacts their lives. So I get to sit in the middle of that thing and of that intersection, and it's such a wonderful and exciting place to be in my career. And if that's something that's of interest to people, I would say just go out and get started doing it. There's not a lot of us out there who are professional science communicators, so it's really valuable to get that experience. Even if it's not something that you end up doing full time, it'll make you a better scientist, and it'll make you a better consumer of science knowledge and science understanding if you've had that experience.